Okay. All right, so I'm going to stop my video too so you guys don't have to look at my ceiling when I'm writing on my screen. Okay, so sharing my screen. Let me pull up my OneNote. So yeah, I really like this, guys, because it's like I can write on paper and it's got lines, so I can make sure I'm writing straight. My graphs look a lot better on here too. Okay, let me see how many people we have in here, and then I'll see if I want to get started. It looks like we only have 11, and I know it's time to start though. I just feel like we don't have a lot of everybody here. I guess I'm recording though, so it doesn't matter, does it? Okay. So today, you guys remember on Friday, we started chapter 12, and we did a problem where we found critical points. So we took the derivative of a function, we set it equal to 0, and we solved for x, and we found what we called a critical point. So the first thing I'm going to do is I'm going to remind us what critical points are, what it means when a derivative is positive or negative in a certain area, and then we're going to do a couple more problems. And if you noticed, I know I said I was going to open this first section of homework if you wanted to get started on it. I didn't because I forgot to mention like an important point that you'll need. And I can't believe it that I didn't mention it at the time, but I didn't. So I didn't want you guys to get into homework and it was asking you for something you weren't really sure how to find. So here we are. Let me do that review, like I said. So what I did when I started class, you guys, was I set up a graph. Oh, that's horrible. Hold on, guys. I have a better way. So you guys, I go to shapes and then it lets me create a graph. It's really cool and it's straight. Beautiful. Okay, so I set up a graph and then I just drew a random function that I made up. So this one, I'll make it different from the one I did before. But I just drew a function. It has some ups and downs. And then I picked some points on the function. So I picked some key points I wanted to talk about. I'll pick these 4. And we talked about how the derivative is affecting the shape of the graph. So we talked about the derivative being, the slope of the tangent line. So at each of these points, I drew what would be the tangent line to the graph at each of these points. And I know that the derivative is the slope of the tangent line. So it can tell me a lot about the derivative when I'm looking at these points. So let's start over here at this point. You guys, the tangent line is pointing down because my graph is pointing down. And I know because that line is pointing down that its slope or the derivative at that point would be negative. So if this function was f of x, then I'm saying that the derivative here would be negative. Now I don't know exactly what that value is because I don't have the exact rule of the function, with numbers and stuff, but I do know it's negative there. And you guys, in this area where our graph is increasing, the slope of this tangent line would be positive. So the derivative here would be positive. And you guys, so we talked about if your derivative is positive, that means your function is increasing there. And if it's negative, then your function is decreasing. But we also talked about these special points. You guys, these points where your graph is changing directions, we called these critical points, and they were places where your derivative actually equals 0 because the slope of that horizontal line is 0. So it's 0 here, it's 0 there, and these are what we called our critical points. I know I at least said the words min and max in our class on Friday, but I didn't specify that you would have to put that as part of your answer. So I want to be clear that each critical point is either a minimum or a maximum. And when you start testing these points, remember we put them on a number line and we looked at where the graph was going up and down. From that, we can figure out, even without looking at a picture of the graph, if each critical point is a min or a max. And you will have to answer that. So while it's not a hard thing to find, I didn't tell you that you would have to say specifically this point is a minimum or this point is a maximum. So you guys, this point here, because it's going from down to up and it hits a low point here, this is what you would call a minimum. This critical point here is what we would call a maximum. So we will have to label those. But that's what I didn't tell you last time. But we're going to do a couple of problems, and I will explain in detail exactly what you need to learn and what you need to know from doing these problems and the way that your answers are going to be written. Okay, so this was just a visual review of what we're finding, but then we do most of it algebraically. So let's start with a function. Let's do f of x equals, I don't know, let's do 3x squared plus 6x. So if I give you this function, and I don't want you to graph it, you know, graphing it is a super easy way to tell where it hits a min, where there's a max, where it's going up or down, you know, guys, but without graphing it, I want to know that information. So in the question, it could be worded a number of ways. It could say, use the first derivative test to find critical points, or maybe it says to find and classify critical points. That's a way that it says it sometimes. It might say something like find increasing and decreasing intervals. So that's another way to word the problem. But either way, we're going to do the same thing. So for every homework problem you have in this section, your first step is going to be to take the derivative. So you start with your original, taking the derivative, and you guys, you'll notice that most of these functions, the derivative is going to be easy to find. It's just going to be some power rule stuff. So take the derivative. You guys, let's do the power rule. We'll get 6x plus 6. And your second step, so after you take the derivative, your second step is going to always be set that derivative equal to 0. So whatever you got, set it equal to 0 and solve for x. So let's subtract 6 on both sides. So I get negative 6 equals 6x. Divide by the 6 and you get x equals negative 1. So you guys, in steps 1 and 2, find the derivative, set it equal to 0. What you have done is you found the critical point. Because the derivative equals 0 here, that means that is a point where our graph changes direction. While I know it changes direction there, what I don't know is what direction it started and what it changes to. So was it going down and then it hit this point and now it's going up? Or is it vice versa? You guys, that's what we use the number line for. So remember, after you find the location of any critical points, we're going to put critical points on a number line. We just have one on this one. The one we do after this one will actually have 2 critical points. But this one's just got the 1. So you guys, using this 1 point on our number line, we're going to find a number over here and a number over here, and we're going to test a value in each interval around your critical point. Remember, it does not matter what number you pick as long as it's in that interval. And you guys might pick different numbers than somebody else would, and that's totally fine. So you guys, something less than -1, I'm just going to go with -2. I'm going to test that. Now, here's the key. first of all, if the problem says use the first derivative test, it's a really good clue. If it doesn't say that though, then just remember, the numbers that you test them in the first derivative. Remember, here's what I want to know. I want to know, is the derivative positive or negative in this interval? So take your -2 and put it into that derivative. Let's see what we get. So for this, I'll get 6 times -2 plus 6. So -12 plus 6, and I get -6. So I put a -2 into my derivative, and I got a -6. Remember, guys, sorry. Remember, it's not that it's a -6, it's that it's negative. It really doesn't matter what it is. I just am concerned with the sign. So I'm going to say, okay, the derivative is negative at that point, which implies that the derivative is negative at all the points to the left of -1. Remember, you only have to test one, and you know that all the others would be the same. So because the derivative is negative there, and I like to just put a big minus over that interval, you could also draw, remind yourself what that means. It means the graph is decreasing, or it's going down at that point. So you guys, I know, and honestly, basically about every problem that you do, if this interval is going down, it basically guarantees that your next interval is going up, because intervals usually do alternate. There are weird cases though, where you might have a graph that decreases on one interval and then it hits a critical point and then it keeps decreasing. So you guys, I don't want you to take for granted that these intervals usually alternate. I want you to test each interval. So let's test a value over here. You guys, anything greater than -1, you can use. Let's use 0. So test 0 into the derivative. So that's going to be the derivative at 0. We'll get 6 times 0 plus 6. So we get a +6 there. It is positive. That's what I'm concerned with. So I'm going to put a big plus over this interval. You can draw it in. Show me that you know that means it's increasing at that point. So you guys, we have a pretty good picture of the graph here. I know that as you go along x values, as you get closer to x equals -1, your graph is going down. And at -1, it hits a critical point, which means it sits still for a second, and then it changes. And on the other side of -1, it starts going up. So from this picture, let's start with the intervals. So if it wants to know, where is this graph increasing? Well, you look at your number line and you find the intervals that you put a plus on, or that you put an arrow going up. You guys, so it looks like to me it's increasing. It starts that when x is -1 and it continues on forever. You guys, it keeps increasing forever because there's no other interval to stop it. There's no other critical point. So I'd write that like this. Remember, that's an interval notation that goes from the left point of the interval to the right. And if it's not actually a point, like infinity, you just write infinity. So let's talk decreasing. Well, that's going to be where your graph is going down, or where the derivative is negative. So you guys, that's going to be everywhere to the left of -1. So because it goes on, all the way to the left, any x value as you go to -infinity is going to be part of this decreasing interval. That left endpoint would just be -infinity. And then it keeps decreasing all the way till you get to that point -1. Remember, we're not going to use brackets, so we never include our critical points in our intervals. We don't say that it's increasing or decreasing at -1. It's just standing still for a minute. But you guys, let's talk min and max. So Another part of the question might say this. It might say, is there any minima or minimum on this function? And let's see what our answer is, guys. Your critical point is going to be a minimum or a maximum, right? And even though I don't have an actual graph of the function, I do have a very clear picture of which one my critical point is. If it is going down and then it hits this point and it starts going back up again, this has to be a minimum critical point. So you can just see it from the picture and you'll know it's a minimum. So if it says, is there a minimum? Here's what it's going to ask for. It's going to say, where does it occur? If it's a question of location, if it says, where is it? That is an x value. Where does it happen? It happens at x equals -1. What if it asks me what the value is? What if it says, well, what's the value of the minimum? Or what's the minimum value? You guys, anytime it asks you for a value, that is a y value. How do I find that? Well, I take the x value where it occurs and I put it into the original function. You guys, if you're looking for an actual value, you put it into the original function. So what is the value there? Well, I don't know, but I can find it. It's just f of -1. So I'm going to do 3 times -1 squared plus 6 times -1. So this will be 3 times +1 because the negative squares out, and I'll get 3 minus 6. I get -3. So where does it occur? It occurs at x equals -1. What is the actual minimum value there? Well, it's -3. It would be a y equals, but I don't think you have to put in the y equals. Now, I don't want the next part to confuse you, guys, because on every question, it will ask if there's a minimum and it will ask if there's a maximum. It asks for both just because if it only asked for a minimum, you would know that you were looking for a minimum. But by asking for both, it's not giving anything away, if that makes sense. So it asked for a minimum and we actually had one. So I answered those questions. It's going to say, hey, does this function have a maximum? Well, does it, you guys? We only had one critical point and it was a minimum. So no, there's no maximum point here. So you would say, no, it doesn't, and you wouldn't have to answer any of the follow-up questions because it doesn't have one. But guys, just because it does ask for both doesn't mean there'll always be both. So I don't want that to throw you off like, well, it's asking for a max, so there has to be one. No, that's not the case. You just say no. Okay, so on this problem, we found the derivative. We set it equal to 0. We found our critical point. We put it on a number line and we tested values around it for the sign of the derivative at those values. And it made us create this. And this is what answered all our questions. So we could answer questions about where it's increasing, where it's decreasing, and questions about if we have a min or a max, where it happens. Well, it happens at the critical point, and what the value is there. If we had found that our -1 was a max on this problem, then we would have done all that over here and we would have said there was no minimum, but it was a min for us. So you guys, I want to do another one. This one's going to be a little more complicated in the solving. So you guys, I want to do f of x equals x cubed plus 3x squared. Let me think. Hold on, let me pull it up. I had this question, I really liked it, and I want to get it exactly right. Plus 3x squared minus 9x plus 4. Okay. I want to answer all the questions about this one that I did about the last one. So I'm going to find critical points first. That's where you got to start. So first step is always the same. Take the derivative. So let's take the derivative. You guys, I'll get 3x squared plus 6x minus 9. And I need to set that equal to 0. So I'm going to say 0 equals 3x squared plus 6x minus 9. You guys notice the solving on this one is different. If you go back up and recall what we just did, when we solved this one, that was just linear, right? We just got x by itself by, subtracting the 6 and dividing by a 6. We can't do that here, right? You guys, because this isn't a linear expression, it's quadratic. It has the x squared in there. So remember, this is where we're going to factor. This is why we practiced factoring the other day. Okay, so when you're factoring, we did some practice with it. And if you remember, when x squared has a number with it, like in this case, we have the 3x squared, it does make it harder. So on this particular problem, and it doesn't work for all of them, but you guys, I think I can separate that 3. I think I can get rid of it. And let me show you how I'm going to do it. Because, and again, this specific problem is going to work like this. Can I take a 3 out of each of these terms? As long as I can take it out of all of the terms, I can factor it out. You guys, that's what I'm going to do. So I'm going to put a 3 out here and call this x squared plus 2x minus 3 in here. And you guys, it makes my factoring either, because this 3 out here, I don't really have to concern myself with it anymore. I'm going to focus on factoring this part. And now my x squared is by itself, so it's easier to factor. So I have 0 equals 3 times whatever I get when I factor this. You guys, when x squared is by itself, remember your first terms are just going to be x times x. And then you find the last terms with factors of -3, and they have to add up to +2. So you guys, what about x plus 3, x minus 1? Because 3 times -1 gives us that -3. And when I do 3 plus -1, I get the 2 I'm looking for. So I factored. Now, here's the thing. Where do I go from here? Because when I practiced factoring, that's all I did was I factored and I just, I was done. But I actually have to keep solving. So now that I have factored and I have it set equal to 0, this is where I take each factor and set each factor equal to 0. You guys, I don't want this 3 to throw you off, because you might think, well, the 3 is a factor. It absolutely is. But you guys, would I take the 3 and set it equal to 0? Well, it doesn't make sense, right? That's just an untrue statement. That just means that I don't have to consider that factor. The reason being, that factor doesn't have an x in it. So in another way of saying this, take each factor that actually has an x in it and set it equal to 0. So I'm gonna take my x plus 3, set it equal to 0, but I'm also going to take the x minus 1 equal to 0, and I'm going to solve both of these equations and get 2 solutions for x. So minus 3, I get x equals -3. Over here, when I plus 1 on both sides, I get x equals +1. So this is an example of a function that has 2 critical points because I found 2 answers for x. Which is fine. You guys, you can have as many critical points as, comes up in the problem. I'm going to put them on a number line. It just means there's going to be more intervals to test, right? Another thing, I know it sounds silly, but when you're putting your critical points on the number line, make sure they're in the right order. You guys, make sure that -3 is over here and 1 is over here. So you can see now that my line is broken up into 3 intervals. You guys, I'm going to have to test a value here, here, and here. I'm going to have to test 3 different numbers. Okay, so let's pick a number that's less than -3. I'm just going to go with -4. Remember where to test it, in the derivative. All right, so -4, putting that into the derivative, let's see what we get. So it's 3 times -4 squared plus 6 times -4 minus 9. So you guys remember that -4 squared is positive 16. So 3 times positive 16, it'll be minus 24 minus 9. 3 times 16 is 48. Minus 24 minus 9. 48 minus 24 minus 9 is 15. And it's positive. So you guys remember, I don't care that it's 15. I care that it's positive 15. So I'm going to put a big, oh, sorry guys, I must have switched my pin on accident. There we go. I'm going to put a big plus in this interval because that means the derivative is positive there. What does it mean for the shape of my graph? It means it's going up in that area. So go to your next interval. Let's find a value between -3 and 1 that I can test. 0 lies in there. That's what I'm going to use. You guys, you're going to have to turn that down. So let's test 0 in the derivative. You guys notice if you put a 0 in for both of these x's, all you're going to be left with is -9. So it's negative here in this mid interval, which means my graph is pointing down in that interval. What did I say about turning that down? You will now. Sounds like an 80s arcade back there. Okay, anyway. So you guys, let's test a value over here. Greater than 1. I'm going to pick 2. So in the derivative, putting a 2 in there, we'll get 3 times 2 squared plus 6 times 2 minus 9. So 3 times 4 plus 12 minus 9. So you guys, that's 12 plus 12 minus 9, and it's 15 again. So it's positive. So that one is going up. So remember, once you actually do this and you put all this information on your number line, you have enough information to answer most of the questions. So let's remember what the questions are. Ooh, you know what I want to do? I want to, so I can scroll down, I want to figure out how to, I might not be able to. I was going to try to like copy this graph and then paste it so I could bring it down with me. But guys, I can't think about things on the fly like that. Oh, guys, look. I didn't know that I could scroll over. Perfect. Now we can answer our questions and we have space. Okay. All right, so questions I might need to answer. Where is this graph increasing? Well, I need to include all the intervals where I have a plus or an arrow pointing up. So remember where my intervals borders are, at -3 and at +1. So you guys, my first increasing interval is this one over here, everything less than -3. So how would I write that in interval notation? Well, I would do -infinity up to -3. But you guys, it's not the only one. And this time I have 2 places where we're increasing. Look over here. Everything greater than 1 is also going to be an increasing interval. So the second increasing interval goes from 1 to +infinity. You guys, if you have more than one interval in your answer, you can union them. And I think MathLab has a template for unioning intervals like that. Or you might even be able to just put a capital U in there and it might understand. I'm not sure. If you can't figure it out, I think putting a comma between them would also be fine. But we do have a decreasing interval, so it asks for that. It's just going to be this area in between. So we have one decreasing interval. It starts at -3 and it goes until 1. Let's find, let's see if this function has any minimum values, or it might say minima. That's just a plural version. So does it have any minimum values? Let's find out. Well, let's see what's happening at each of these points of change. This graph over here is going up and then down. So the point would be up at like on a hill. I don't think that's a minimum. Let's check the other change point where we go from down to up. Yeah, that's going to be a minimum point. So it looks like my minimum occurs. So yes, we do have a minimum. It occurs at x equals +1. What is the minimum value? Well, I don't know, but I can take this +1 and put it into my original function. So it was 1 cubed plus 3 times 1 squared minus, minus 9 times 1 plus 4. So remember, when you're looking for the actual min and max values, you put your critical point x's into the original function. So sometimes, and I know it can be hard to remember, well, do I put this into the derivative or do I put it into the original? If it's a test, you're putting it into the derivative. If you're just looking for a min or max value, we just put it into the original function. So here we're going to get 1 plus 3 minus 9 plus 4. That's going to be -1. So what is the minimum value? It's -1. On this one, you'll have an answer for both the min and the max question. So does it have any maxima or any maximum point? Yes, it does. Where does it occur? Well, it occurs at, and then you go over to your number line and you see that it occurs at this one where our graph is going up and then it goes back down. It occurs at x equals -3. What is the value there? What is the maximum value? Well, I don't know, but I can find it, right? Go to your original function and put in your critical point x. So see what happens at -3. So we're going to have -3 cubed plus 3 times -3 squared minus 9 times -3 plus 4. So let's see. Guys, remember when you're cubing, if it starts negative, it's still going to be negative. So this is going to be -27. But when we square the -3, this is going to be 3 times +9. These two negatives make this a +27, and we have +4. So we have -27 plus 27 plus 27 more plus 4. And what that's going to get us is 31. So yes, it has a max. It occurs when x is -3, and the value of that max is 31. So you guys, these are all the different values you will need, or pieces of information that you're going to need to answer any question that the homework throws at you. Will it ask every one of these things in the same problem? Maybe. Maybe not. Maybe it'll just ask for increase, decrease. Maybe it'll just ask for min and max. Either way, you can answer whatever it asks of you. You guys, I think the biggest thing that can happen on these problems is confusion about like the fact that we're really always dealing in x values. We only find a y value when it specifically asks us to. Your intervals are always in x, stop. Okay, sorry. Your intervals are always in x values. They're always talking about going left to right, never about going up and down. Don't let it confuse you guys. Let me think about how there's ways that it confuses you. Like for one, when I said that this x equals 1 is a minimum, but -3 is a max, remember, it's not about the fact, I mean, you might say, but 1 is bigger than -3. How could 1 be the minimum and -3 be the max? Remember, that's not what it's asking. That's just where the min and max occur. How can I know for sure that this one is a min and this one is a max? Well, because the actual value of the minimum is -1. The actual value of the max is 31. These are the ones that are being compared to each other. The 1 and the -3, that's just where they happen along the way. You guys, that's just a left and right situation. Please don't get that confused with, you know, up and down, because that can really throw you. You know, you've got these two critical points at 1 and -3, and it says which one's a min, which one's a max. Don't just think about which number's bigger, because that's not going to get you the answer most of the time. So let me see. Also be careful about increasing and decreasing. You know, this interval here from -3 all the way to the left. If you think, oh, everything -3 and lower, that doesn't sound like an increasing situation. Just remember, that's only where it happens, not what the actual values of the graph are. So just remember, x is just left and right. It's not about, you know, actual values being greater or less than other values. It's just where everything's happening. And usually it's basically what we're concerned with is the left and right, you know. Where does this happen? Sure, I might want to know the value at some point, but I really want to know where these things are happening. And we always talk about location in x's. Okay, guys, so that is going to get you all you need for 12.1 now. So I made sure I actually got everything in today. So I will be putting your homework up here in a minute. You should see it. Not that you're just checking, you know, excitedly for your homework to come up, but it'll be up soon. And you can start working on these problems. And then on Wednesday, we'll do 12.2.